Let's do example problem 13 on page 88. Here's the problem in the book right here. And I'm just going to read it. There's a lot of writing here that you don't really need. It says, system of two objects suspended over a pulley by a flexible cable as shown in figure 23A. There's 23A. Okay, sometimes referred to as an Atwood machine. Consider the real-life application of an elevator and its counterweight to minimize the work done by the motor to raise and lower the elevator safely. The mass of the elevator and the mass of the counterweight are similar in mass. We leave the motor out of the system for this calculation and assume that the cable is negligible and that the mass of the pulley as well as any friction is small and ignorable. So we're simplifying this problem basically. These assumptions ensure that the tension in the cable has the same magnitude on both sides of the pulley, which is essential for solving the problem. Let the mass of the counterweight be 1,000 kilograms. Assume that the elevator has a mass of 850 kilograms and its mass when carrying 4 passengers is 1,150 kilograms. So that's the mass of the elevator. For the latter case, calculate the acceleration of the elevator and the tension in the cable. This is assuming that you're just releasing it. So this is kind of a contrived example. So let me start with step 1. Given. We're going to give and find and solve. So we're going to have this big pulley up here. And we've got this elevator with people in it. Now obviously this is not a real elevator, although they do use counterweights. So this is a super simplified elevator. And then over here is this counterweight. And the mass of the counterweight is 1,000 kilograms. And the mass of the elevator is 1,150 kilograms. So if, let's say the pulley, this is a pulley that can turn. If I release this, what's going to happen? Well, the elevator has more mass, so it's going to accelerate down, but the counterweight is going to accelerate up with the same acceleration. And so what are we trying to find? We want to find A, the acceleration. Now they have the same acceleration, just one is up and the other's down, but they're tied together by a cable that's not going to stretch. So we're going to assume that if this is accelerating down at 3 meters per second squared, this will accelerate up at 3 meters per second squared. Does that make sense to everybody who's paying attention? Okay, good. All right, now part B. We want to know what is the tension in the cable. I'll call that F sub T for tension, force of tension in the cable. Now let's solve. I have done step 1. And by the way, if I'm in the middle of this recording and the lunch bell rings, you guys can go. I'm going to finish it, but I think I can get done. We'll see. So so what do we do? Well, we're going to draw a Freebody diagram. Let's do the counterweight. So this is step 1. Step 2, draw a Freebody diagram, and I'm going to pick an object to look at, and I'm going to pick the counterweight. And when I look at just the counterweight, I ignore the elevator. Just look at the counterweight. We know it's going to accelerate up, but we've got 2 forces acting on it, right? We've got the force of gravity, and on the counterweight, I'll call it F sub G for force of gravity, subscript C for counterweight. And then we've got the tension force. Now, here's a hint. If something accelerates up, make that your positive y direction. I know this is going to accelerate up, so I'm going to say this is positive y. And the x direction has no relevance in this problem. So I'm just going to leave it alone. So this is step 2. Doing this. Step 3, deciding what direction is positive y. That's step 3. I don't need to break up forces into their components. Everything is just right. Now I'm going to do step 4. I'm going to sum the forces in the y direction equals ma in the y direction. What am I looking for? I'm looking for A. This is what I'm trying to find. Okay, so that's good. Then you look at the free body diagram. This equation tells me what to do. It says look in the y direction and add up the forces. Well, I got the tension force minus, now what is the force of gravity on this? Well, it's equal to the mass of the counterweight times the gravitational field. So I'm just going to call this mc times g equals mc, right, because it's the mass of the counterweight times A. And that's what I'm looking for. Now I've just completed step 4. Now step 5, solve for your unknown. Well, what do we want to find? We want to find the acceleration, but there's a problem. I know the mass of the counterweight. I know g, 9.8 newtons per kilogram. I know the mass of the counter, but I don't know the tension force. I've got 2 unknowns in one equation. I can't solve it. So what do? I need a second equation, right? So I'm going to draw a free body diagram of the elevator. This is a pretty sophisticated problem to start off with the procedure. Look at the other examples too. They're a little simpler. So I'm going to come over here and I'm going to draw a picture of the elevator. Here's the elevator. There's with the people in it, right? So I've got the mass of the elevator times g. Do you see that's a force of gravity? Sometimes I just write it mg. If they give me the mass, I just write the force of gravity as just m times g. And then I've got the tension force pulling up. Now, which way is the elevator accelerating? It's accelerating down, so I'm going to go ahead and make positive y down. I just did step 2 and 3. Step 2, draw the free body diagram, show the forces acting on the elevator. Step 3, decide which direction I'm going to make positive y. And again, x is irrelevant. So let's sum the forces in the y direction equals ma in the y direction. If you know the direction of the acceleration, try to make that positive y or positive x, depending on the problem. It makes the problem easier to solve. I look at my free body diagram. It's the mass of the elevator times g minus, do you see why it's minus the tension force? Because it's in the negative y direction. Equals the mass of the elevator times the acceleration. Well, look, this is good. I'm trying to solve for the acceleration. But I don't know and I know the mass of the elevator. I know the mass of the elevator. I know what g is. But look, I don't know what the tension force is. But what do I notice about these 2 equations? 2 equations, the same 2 unknowns I can solve. Here's what I'm going to do. I'm going to solve for the tension force over here, because it's easy, and substitute it over here and solve for the acceleration. And I'm going to do this kind of fast because I'm running out of time. The tension force is, it will add mcg on the other side. So this is mc g plus mc times the acceleration. And I'm going to put this over here. So this gives me the mass of the elevator times g minus all of this. Do you see how I put the minus in 2 places? You see the algebra I did? I did a substitution. Now the only unknown is A. Now I use step 5. I'm just using my awesome algebra skills. So I'm going to go ME minus MC times G equals ME plus MC times A. Do you see the algebra I did? I put this on the other side. I factored out the G. I factored out the A. So A is equal to ME minus MC over ME plus MC times G. Now I can plug in my values. This is, well, what's, I'm just going to do this in my head because I'm running out of time. ME minus MC, that's 150 kilograms. ME plus MC, that's 2,150 kilograms. Times G is 9.8 meters per second squared. And I'm running out of room here on my paper, but that's okay. I'll just put it over here. A, I'll squeeze it in here. A equals 150 divided by 2,150 times 9.8, and I get a nice gentle 0.684 meters per second squared. That is the acceleration of the elevator down. That's a very nice acceleration. Lastly, I take this acceleration and I plug it. Now, the bell's about to ring, so I'm going to stop here, but here's what I'm going to tell you what to do. So just hold on just a second, like 30 more seconds. Now you know what the acceleration is. Take that acceleration, plug it in here, and solve for the tension force. Or you can take that acceleration and plug it in here and solve for the tension force. And you've done it. And that's a very hard problem. And there is a shortcut. I'll show you that one later. That is all.